Hi, everyone. Good afternoon. Hope you're all enjoying the 2019 Sloan Sports Analytics Conference. Here to give our next competitive advantage talk is Akshay Patel from the Action Network.
Thank you for that intro. Thanks. Yeah. Hello, everyone. Thanks for coming to the talk. My name is Akshay. I'm an engineering lead here at the Action Network. There's a lot of you here. I'm kind of surprised considering it's Bill Simmons talking soon. So in case you're here for the Bill Simmons talk, wrong room. If you're here for the Action Network win probability talk, I'm the right guy. And hopefully this will be informational for you and you'll get to learn about our features. Let me tell you a little bit about our company, and then I'll go into what win probability is and why we built it, who our users are. So the Action Network is a company that's built on lots of sports betting data. Our focus is sports betting users. We've gathered around 15 years of sports betting data that's real-time, correlated with other pieces like weather, fantasy player stats, things like that. And our goal is to provide sports bettors with an edge on what they're doing with either following the game, betting on the game, or what sort of predictive analytics they rely on these games. So let me go into a little bit of detail around who our users are, what they care about, and why they use our platform. So here's a quick slide kind of talking about who our users are. Some of the key numbers that I want to talk about here. An average user on our platform uses our app for about 13 minutes and 29 seconds a day. Now, most of you have cell phones in your pockets. Think about apps that you use for 13 minutes. They're Facebook, Twitter, just things with feeds that you're scrolling nonstop. So 13 minutes is a lot of time for a sports fan to be opening our app for every single day. An average user also visits our apps and our sites for 30 times over a month, which is pretty much every day. I can't think of a game I want to follow every day, so props to these users. And a weekly user also comes back to our app 5 times a week, which is an interesting number as well. So just kind of going over some of our basic sort of marketing numbers here. If you look at the amount of time a user spent in our app, it was 2.4 years just for one game. That was Super Bowl Sunday. A lot of people joke that the Oscars is a Super Bowl for the movie industry. The Super Bowl is the Super Bowl for the sports industry. So that's a lot of time spent in a single app just for one sporting event. And we don't even show any of the ads. So to give you sort of a gist of how many bets people track in our platform, over the last football season, these numbers are sort of compressed, not over our entire platform's history, but over the last football season, users in our app tracked 9.5 million bets. As you can see from some of these numbers here, that the Chiefs-Rams game was one of the most bet games. These also don't include things like college football, which there's a large volume of games of. So just from a single game perspective, that was an interesting game. It does not include numbers from the Super Bowl. We're not quite sharing those yet. Unsurprisingly, the Patriots are the most bet team in the NFL on our platform. For those of you that are local, I'm sure you bet on them quite a bit. So let me talk to you a little bit about win probability, why we built it. The primary use case of our platform is to follow a game from a bettor's perspective. We realize that looking from our numbers, a bettor that tracks a bet within our app opens it 223% more than a bettor that doesn't track a bet in our app. So that's a really interesting number because obviously someone that's tracking bets in our app is highly engaged. They're coming back over and over during the duration of the game. Maybe it's to see if their bet's losing or winning. Maybe it's to figure out what the score is impacting their custom bet. So a normal bettor's use case, come into the app, log a bet, edit a line if you can't see the line that you bet on in our app, and then you customize the amount you bet on, and you track it. So a lot of things happen once you start doing that behind the scenes. As soon as you track a bet, our backend system registers you for alerts. So if you have push notifications turned on, you'll get game start alerts, scoring alerts, game end, all the standard stuff that happens with the sports app. The things that we do on top of that are we'll throw in the current line. So when the game goes live and you're following along and someone scores a touchdown, you'll see how your bet is trending up or down based on that line. And we've seen people just tap into those, and like on Sunday at 1 o'clock when a ton of the early games are ending, our backend servers are always melting. It's just people constantly refreshing, trying to see what their bets are doing. so we realized that people are very, very engaged with tracking the status of their bets, and why not make it a better experience for them throughout the period of the game? And one of the things that we wanted to do was give them a real-time version of what their chances of winning that bet are over the period of the game. So unlike traditional win probability, the thing we built is a cover probability, and we're talking about how well your bet's gonna do throughout the duration of the game. And really what it lets the users do, it lets you correlate interesting events in the game with how your bet is doing. What you do with a win probability chart, like ESPN has, for example, you can see the scoring rate and how a team is trending on winning or losing throughout the duration of the game. Same sort of idea. So give you a few examples of how users use these. We call it live sweating. If you have a bet on the game, you're quote unquote sweating your bet. You're at a bar watching for basketball towards the end of the game. You don't know if the total is going to go over or under. And the closer it gets, the more you want to know what's going to happen with your bet. You can see one of the users here is talking about walking a narrow path because their bet is right around that 50% whether they're going to win or lose. So we've seen a lot of users go on social media, share screenshots from the app about what the chances of their bet winning are. Someone scores a touchdown, someone has an interception. All these things kind of taken into account, and their win probability always changing. And they have something to keep track of now during the game, unlike just saying, hey, here's your bet, and you may or may not win. So highly engaging user experience for our users, and a good reason for them to come back to the app. So let me talk to you guys a little bit about how we built it. And I'm going to go into technical details, and if anyone wants very specific things, we can chat after the talk. But here's sort of a high-level overview. Like when I started the talk, I said we had over 15 years of sports betting data, so that's our data warehouse. We take that data warehouse data, and we've generated custom algorithms for each sport. Now, we run machine learning on that data set. We've generated a bunch of coefficients. That's sort of your quote-unquote basic data science story. What we've done from there is when a user registers a pick with our API, we store that in our database. You come back, and then you're trying to check what the probability of your pick winning is. We'll take your bet, we'll look at the line, then we'll look at these coefficients and figure out, based on what line you got, what coefficients we need to map them to. Based on the sport, we also take into account the real-time situation of the game. So if you look at football, the down, the distance, the yard line, the period, the amount of time left, weather, all sorts of things that impact the outcome of a game, we'll feed that into our data model as well, do some linear regression, and spit out a basic number, which is what you guys saw from as a result of the win percentage. So let me go into more details around each specific part of this. So technical background here. For folks of you that are data scientists in the audience, data science teams and engineering teams at companies that build apps normally work in vacuums. And the engineering team builds products, the data science teams come up with amazing insights. And when you need to tie them both together, there's always this weird friction. And I speak that as an engineer, so no bias. But for things like win probability to work, you really need to collaborate. Believe it or not, this is one of the most important things to get features like this working in real time. So we worked with our data science team, figured out a data model that works for both our real-time data and for testing it against our 15 years worth of data. And what that does really is you have this common language you both speak. So when it's time to put this thing in production, you have a contract that you both agreed to, which really makes implementing features like this super easy and to iterate on. So just we both agreed on a data format that really helped us get this out quickly. It sounds really trivial, but really it goes a long way. So if you guys are working on products that need data science to go into your production apps, please work with your data scientists. They will love you for it, because then you can change this in production without having to think about it too much. What this ended up also doing for us is, once we feed it into our machine learning algorithms, spits out a generic JSON file, and it has tons and tons of coefficients, and it lets us look these numbers up really easily to figure out what we need to multiply a bunch of these numbers with, run linear regression on the fly, and give you the chances of your bet winning. So let me talk a little bit about the technical stack here. We use Python and TensorFlow, like a lot of data scientists do, to generate our machine learning algorithms. What these do is they're just going to generate coefficients. And the coefficients, we've broken them down by period. So if you're in the first quarter, it's a different set of coefficients. If you're in the fourth quarter, a different set. If you're going to go into overtime, it's a totally different set. So we've kind of built all these permutations of coefficients that are really the key to how the algorithm works. And for the to make this as real time as possible, this is really the key here for us, because when you have millions of users tracking these bets, you want to give it to them as fast as possible. We've seen people complain on Twitter when our data goes a little bit out of sync. They're like, oh, your win probability algorithm is not giving me the right thing. And they get all upset. So really, really important here to make it as fast as possible and keep that whole connection between your machine learning algorithm and your real-time data as clean as possible. So what we do with these coefficients is we put them into an in-memory database. What that lets us do on the technical side is it's running on our machines. We can look up by feeding in the situation of the game, and we feed in your pick. And because it becomes a simple lookup, we don't have to go to a database in a different location. We don't have to go hit external services to figure these things out. It's able to retrieve all these values very, very quickly. So on an average Sunday, we have about 10,000 requests every single second coming in, which really, really, it needs to be fast. We don't need to be melting our databases, accessing all this stuff all the time. So that in-memory database, key. We've also made all our coefficient data aware of edge cases, so shootouts in hockey, overtimes, things like a punt return that somehow went in a bad direction. So all these situations we've taken into account, and a lot of that comes in for free when you run it over 15 years worth of data. You run through games that happen to run into these situations, and it generates a data set for you to make a predictive algorithm. What we do with these coefficients after is when a user is accessing our API, which is written in Node.js, and the bet info is passed into a custom function, it looks up the real-time game data, finds all these coefficients, runs linear regression, which is just a fancy word for multiplying a bunch of numbers, and spits out a win probability, which is what you end up seeing as a user. So very, very sort of tight set of things that we need to do here. And it runs extremely fast. It takes milliseconds typically for the user to figure out, for us to figure out the user's win probability because of how we've designed this architecture. There's a lot of things that are missing in here. So some things that we've talked about doing that the current system doesn't do is we need to generate these coefficients manually. Like I was saying earlier, we run it through TensorFlow and Python. It's sort of a one-time thing, and when we need to update it, you have to run the algorithm again with a new set of data, and then it spits out different coefficients. It's manual. What we thought about doing here, and it's something we're trying to implement right now, is run it every night. After every set of games that's over every single day, run this machine learning model, see if there's a massive difference in coefficients. If there is a difference, then flag someone on the data science team and have them see if we need to take this into account already, if the algorithm needs to be tweaked. Because the thing with data science is you want this to be evolving all the time. Game models are going to change. Players playing in these games are going to change. And you want to make sure that you stay as current as possible. So we're still designing the system, but the idea is going to be give our data science team immediate feedback after running through our data set every single night. They can review it, and then we can feed back their updates into our system so that when the users come in the next day or 2 days later, we have more up-to-date versions of these real-time models. The current model we use also only supports game bets. We're working on adding things like player projections. Prop bets are extremely popular with people in the betting community. How many three-pointers someone's going to get is a fun bet to track as you're going along with the game. So we don't quite support prop bets, right? Or we support prop bets as a tracking feature, but we don't really give you win probability for it. That's another thing we're trying to figure out there. And the nice thing about the architecture that I went over with, it works great. We can use the same architecture. Instead of plugging in the game model, we can plug in the player's stats model and the pace at which they're scoring, and that'll help us generate a win probability as well. One thing that we've also talked about is, I told you earlier that it takes milliseconds, but as our user base grows, it's a very linear issue here. Like, more bets you have, the more you need to run these algorithms, and we need to get smart about it without having to add additional load on our infrastructure. So what we talked about is look at all the users that are on our platform. There's definitely people making bets that are extremely similar spreads, similar money lines, group all of them together, and then perform calculations once, and then keep them once, and anyone accessing them after, try to display them as fast as possible by just computing it once. What this does is reduces our AWS bills, which, as you're growing, is something you really, really need to be careful with. Some users have also reached out to us and asked us, what if I don't bet on this game? From what I was saying earlier, the users that primarily profit from this feature right now are the ones that are tracking bets. But we'd like people that are not really betting, just tracking games in our apps, also to benefit from these features. So sometime next week, we're launching this in the app where we assume that the bet you got was the last line that you could have gotten for the game. And from then on, with every play that happens, we're gonna use that as the assumption of what the bet is and generate a graph for if you had a spread bet, a total bet, or a money line bet, how that progresses over time. So as a user, that's advantageous because you can go back to games yesterday and see how a bet would have trended based on how our algorithms are running. So that kind of gives us an edge, which is what we are trying to give you as sports bettors. Give you as much information as possible, try to visualize it in a way that makes sense to you, because at the end of the day, it's really fun to track these games, and all you really want to know is, am I winning or not? That's all, and happy to answer any questions if you guys have any. Yeah.
So is it the assumption that, like, when they're tracking the bets live and they see that their bet is doing, like, very poorly, they might bet on the other side?
That's a good question, and I'll repeat the question. So the question is, if they're tracking their win probability there, are they going to try make a bet on the other side? That is something we've seen people do. It's hedging your bet, essentially, and if you are tracking a bet in the wrong direction, or for some types of bets, you may have even lost it, like a win total. You could hedge your bets, and we've seen people do that, absolutely.
So the bottom line of the app is to help sports bettors, right?
Yep.
Do you plan on having, like, recommendations for that in the future, or is this more in the future just to keep people interested in the app itself?
Sure. So the question is, do we have recommendations? So we have recommendations pre-game. And a lot of this data feeds into, the same set of data feeds into pregame recommendations as well. That is our business model. That is what we charge our users for. And yeah, we absolutely have recommendations. Things that we plan on doing better are giving you in-game recommendations if your bet's winning or losing based on the win probability. Yep. Sure. Sure. So the question is, does our app show implied win probability or implied money lines, and what are the gaps there? Yes, we do. Again, it's something we show pregame right now. We have our own projections pregame, and we compare that with the current line and tell you whether it's a good line to get or not. We don't do it quite yet with live lines. That is something we're most likely launching next week, actually. So great question. Sure. We do not expose any of our algorithms to the outside, and nor do we expose some of our data, but that is something that we have talked about internally, and we may expose our data, but not exactly our algorithms, because that's really a special sauce. Sure. Sure, so that's a great question. All of our data from a warehousing perspective is stored in a Redshift database. For our real-time access data, we use a Postgres database, and it's been pretty fairly normalized so that both the real-time database and the warehouse are very similar. And that was a bit I was saying was a collaboration between our data science team and the engineering teams. We wanted to make sure that those are very, very similar so that when we're running analysis, the tools match up and the data schemas match up. Yep.
3 years from now, what kind of improvements do you see for your making sense now?
Could you repeat that question? Sorry.
Like in a broad sense, like 3 years from now, what kind of things do you think that you'll be able to improve on that you don't have now?
I think the biggest one is going to be able to tweak your model on the fly. I don't know if you guys saw the FIFA talk, a couple talks before this, but they were going over how the tightness in formations for some of the soccer teams impact how the winning chances of a team end up being. I think feeding in real-time stats or more advanced stats like player position tracking, things like that, as that becomes more prevalent, will end up changing how win probability works for us. And as more of that data becomes available, we'll absolutely need to keep up with it and update our algorithms. Yep.
So you mentioned how you rerun the machine learning algorithms every night to update the coefficients.
We do not do that yet. That is something we're planning on doing right now, though.
So how would, if you have 15 years of backlog, how would one night affect the coefficients?
It absolutely won't. You're right. But it will give us an indicator on whether we need to revisit any edge cases or not. So it won't change the base model, but you do want to be constantly updating it. And whether it's a day or a month or a whole season, it's just an indicator to our data science team to flag that, hey, this model did not exactly work for this specific game. You need to look at it and figure out how we need to tweak some of the special sauce so they can work for us. Yep. Yeah. Mm-hmm.
The first decision I think you got to make is whether or not you take into account the team and their talent.
Sure.
Or line.
Yep.
Talent differential.
Yep.
Not every game doesn't start with a 50-50 chance of winning.
Yep.
When Alabama plays a football game in college football, they're 95%.
Right.
So do you guys take into that account? Or I haven't used it, so I don't know.
That's okay. Yeah.
You start at 50-50 or...
So we don't do that for every sport. Football particularly, we don't. That is something that we want to do. For things like baseball and basketball, we absolutely take into account the lineups and the starting players as well.
At his point, after game one of the season, right, the coefficients change dramatically.
Exactly. Yep. So the postseason is a whole special ball game for us, where we don't use the same coefficients between postseason and regular season, because there's a significant difference in gameplay style, lineups, and the players playing in there as well. So we use a less aggressive version of coefficients for our postseason analytics, and that kind of helps us even out some of the win probability there. Yeah?
Do you have any win probability models that are simulations? Do you just find your probabilities?
So not exactly. That is something we've talked about, and that's sort of the start of charting out games with the closing line that we're doing right now. Is it's the start of providing a simulation by just using an existing game. We do some simulations for things like March Madness brackets, but it's not exactly a win probability algorithm for real-time games. Yeah, a great question though. Yeah. I do, yes. I'm a casual gambler, though. I like betting props, which is why I selfishly would love a player prop win probability algorithm. And I mostly like betting on football. Other sports, I'm not great at. Yeah. Cool. Go ahead. Yep. Sure, that's a really good question. The permutations are they're around, so the biggest ones are preseason, regular season, and postseason. The rest of it are dependent on the situation. So baseball has the most number of permutations because we take into account people on base and other variety of other factors like the pitcher's hand and things like that. So we do generate it based on the sport. Baseball and football are the most complicated ones just because of how the sports are designed, and basketball and hockey are slightly simpler because you can take into account the pace of the game and the clock left and things like that. Cool. I think that's everyone. Thank you. And catch me outside if you have questions.